Here's another quadratic example. We have x squared minus 3x plus 4 is less than 2x plus 10. So here, instead of comparing the quadratic to a horizontal line, we're comparing it to a diagonal line. So we have the equation x squared minus 3x plus 4 that we're going to graph, y equals x squared minus 3x plus 4. And that is the parabola that you see here in red. And then we have the line on the right side, which is, use a different color here, 2y equals 2x plus 10. So that would be the blue line here, y equals 2x plus 10. You can see that you can kind of confirm that that makes sense because it's going through a y-intercept of 10. It has a positive slope. If you look at it closely, you can tell that that is a positive slope of 2. So we want to know, because of the inequality symbol here, which is a less than, we want to know when is this graph, the parabola, underneath the line. Okay, so when is the parabola underneath? Because of the less than, we want to know when is it underneath. So looking at that, that would be this region of the graph. Just a single region, interval of numbers. But we need to look at for the intersection points. So I didn't label them here. I have Desmos, so we should label them ourselves. Look carefully at your x-axis. Even though it looks like this is a single tick of 1, it is, because we have up to 5 here, 1, 2, 3, 4, 5, so that we'd go backward, -1, -2, so this would be at -2, or -1, I said the wrong thing. But going up, the ticks are not by 1, they are actually by 2, because by the time I go 5 ticks, I'm at 10. So this would actually be a value of 8. So make sure you read your grid carefully. This point here, where they cross as well on the right, would be at, let's say, 6, because we're 1 past the 5 on the x-axis, and on the y-axis we're 1 tick above, but remember the ticks represent 2, so that would be 22. So our x values of the intersection are -1 to 6. Remember, it's the x values we care about in terms of solving this, because we're trying to solve for x. So the solution set should be from -1 to 6, and we want to include all values between them, but because it has no equal sign on the inequality, it's a strict inequality, we would not include the endpoints. So the solution set would be from -1 to 6. If we wanted to check that, we could plug a value that's in here into the original inequality and see if it works. For instance, we could plug 0 in. 0 is within that interval. 0 squared minus 3 times 0 plus 4. I'm going all the way back to the original inequality. Is that less than 2 times 0 plus 10? So calculating each side, on the left-hand side, 0 minus 0 plus 4, I just get 4. And on the right, 2 times 0 is 0 plus 10. Is 4 less than 10? Yes, it is, so that checks. If you want, you could also check a value on either side to make sure that it is truly not a solution. So for instance, a value that would be outside on the right side would be an x value of 7. So if I plug it in, 7 squared minus 3 times 7 plus 4 is less than 2 times 7 plus 10, this should be a false statement because it's outside of my solution set. Let's take a look. 49 minus 21 plus 4, is that less than 14 plus 10? 49 minus 21 is 28, plus 4 is 32. That is not less than 24, so that also checks because it is false. We wanted it to be false because we were using a value outside of the set. So this is correct. So you can't check every value, again, when you're working with inequalities, but you can check a few to make sure that something that's in the set gives a true statement, something outside of the set does not.